Somebody in Germany watched one of your videos.
Yeah, I did.
I told a friend about
in
it.
Saudi Arabia to watch them.
One of my friends in Germany watched it.
Whatever.
Look, okay, if you want it.
All right, so last time we did chapter 10. So what we got? Any questions from homework? I'm sorry. Does somebody? Yeah.
It was 9.6, number 49.
Oh yeah. So here's kind of a cool thing. You guys might know this property of right triangles. Right, this old Greek dude. It's actually his followers that did a lot of the work, but he got the credit. Oh well. Old Greek dude came up with a relationship between the sides of a right triangle. Somebody know what that relationship is?
A squared plus B squared equals C squared.
And a cool visual to have is if I pull off of here a square that has side length A, what's the area of that square?
A times A.
A times A, so it's A squared. You with me?
Mm-hmm.
If I do the same thing here, B by B, that area is B squared. And then do it here, that's roughly right. C by C, that area is
C squared.
So if I add that area to that area, I get that area. So it is the sum of squares. It's kind of cool, right? The big ass square is the sum of the two smaller squares. Kind of nifty. So, of course, they give me a triangle that's got semi-disgusting sides. I got 17 there. But then you just plug and chug. You just plug it in. The most important side is which side?
Hypotenuse?
The hypotenuse, the biggest dude. I don't care which one of these you call A or B. I don't care. Because they're just being added. Who cares if you switch them? But that guy is the biggest dude. He must be what they add up to be, right? Otherwise, you get really weird-ass answers. You get negative side links. So you just got to throw stuff in. So how is this going to get rewritten? What goes in for C? 17. Good. So you can call that one A. So there'll be x squared plus 2x minus 1. So you got to do that square. You got to FOIL that out. Probably got to get it equal to 0, right? Because you're going to have squares in there. You're probably going to have to factor that thing. Probably got to be a little gross with kind of big numbers.
Which question is that?
49, sorry, in section 9.6. Okay, cool. All right.
48.
Yep.
48 some such.
Okay. Yesterday we did 47, so it's a trifecta. All right, let's see. Still some space back here. So in general, let me ask you, there's a homework problem. I thought there was somewhere about 2 consecutive even numbers somewhere in there. I can't remember. Yeah. But consecutive integers. So somebody just give me an integer.
2.
2. What's the next one?
3.
What's the next one?
4.
So if you don't know what the first one is, what would you call it?
X.
And what's the relationship? How do I get to the second one?
X plus 1.
All right. So then this problem just says the product of those two. The product of these two consecutive integers is 156. So how would you set that up?
X plus 1
Careful.
equals...
What's product mean?
Oh, times.
Yeah, so the x times x plus 1. So then do you say, okay, x equals 156 or x plus 1 equals 156? Yeah. Is that what you do next? What's wrong with that? It's supposed to be what here? What's supposed to be here before I can do this? 0. Right, so this is something that somebody factored too early. So you got to multiply this back out, suck the 156 over, refactor it. How are we doing there? Is that cool? You can only do this kind of thing if this is 0. because that's the only time you'll know something has to be true. One of them has to be 0. If it equals anything else, they could be almost anything. Now, just going off of this, what if I instead, so that's that problem. You've got to finish that out. That's that problem. What if instead I said consecutive even
Oh, okay.
integers?
X plus 2.
So the first number, somebody give me an even number. What's the next one?
4.
What's the next one?
6.
So they're always separated by,
2.
so if I know the first one is X, what's the second one?
X plus 2.
Yeah, so some of you guys got homework back and I said even numbers aren't separated by 1, they're separated by 2. Now here's the evilness. What about odd numbers?
Same thing.
Same thing. People say 3 without thinking. Give me an odd number. 3. What's the next one? 5. They're still separated by 2. It's just if you start odd, you end up odd. If you start even, you end up even. Maybe. So if this problem said odd integers, you actually have the same exact setup. And then it said they sum to be this or something. They multiply to be this, whatever. All right, how are we doing there? So this is what math does first. This represents any consecutive even integers. 2 and 4, 808, 810. So then the equation comes from a restriction. I say, no, not any. I want the 2 to multiply to be 80. So then I say x times x plus 2 equals 80, and then I can figure that out. Right? So math says this is every possible set of even numbers. And then the equation comes from, oh, I want the 2 that do this. And that's why I only get my 2 answers. Maybe. Okay. Yeah, man. Sounds great. Okay, anything else from homework?
7.2, number 70.
Yeah. It's a good little review problem here. You guys try this one out.
Yeah.
All right, give that one a try.
Is that divided by?
Yeah, divided by. So while you guys are kind of setting this up, when there's a problem like this where the factoring is a little bit involved, I might break it up into 4 little parts. So I can just focus on each factoring problem. And then I'm going to put them back in when I get them all broken up. Right. It's just sort of
Yeah,
organization
you can
stuff.
go.
So that. So we'll do that like this. Okay, sure. Yeah, that's good. But you forgot the little y, dude. What's your y? So it shouldn't just be 2, 2, 2. It should be 2y, 2y, 2y. Yeah, there, and he'll be there. Yeah. Well, there's a square, then 4y squared.
Okay.
So if you're not good at factoring, this is like your worst nightmare problem. Right? So it's 4 factoring problems in one. What's this first dude? What form? Cubes. So I put
Little dude.
Big dude.
little dude, big dude. I love that you guys humor me with that. And of course, one little thing. This will be XXX. This is
2y,
2y, 2y, 2y. You could do 2, 2, 2, y, y, y. As long as you remember they got to go together. Right? So little dude's going to get
1x,
1x plus
2y.
1, 2y. So then these go here. These go there. 2y times 2y is 4y squared. It's always a positive, right? That's your up from soap. And then what's the middle dude? Minus 2xy. Kick in
Oh, got
ZX.
it.
Alright. So 1 of each, 2 of each, because there's 3, that makes sense. Product in the middle. Make the sign different so that something rhymes with little letter. Yeah.
When you do one of each in the first one, can you do x, y plus 2?
No, because that would mean that I had x cubed, y cubed. X's are all by themselves, right?
Yeah.
So that's why that x is by itself. 8 and y cubed are together. That's why the 2 and the y are together. So that this way I get my 8y cubed at the end. Cool. Alright, so that's the first piece. How do I factor this guy? Oh, I left out a 2. That's good, Jeff. Yay, Jeff. So what do I have to do first?
Distribute. Oh, we multiply.
Oh, I see. Yeah, so 2 times 2. And of course, factors of 4 that add to be 5 have to be 4 and 1, right? So then I can take this one. Oops, xy. So always make sure that the middle, these are just the coefficients of the middle. Make sure that whatever this is the same here and here. 4xy plus xy is 5xy. That's y is completely legal. I could have put 2xy plus 3xy there. That's still legal, but why is that not smart? Because those are the only numbers that make the grouping work. Maybe. So why do I know I can do grouping here? Because now I have 4 terms. So there's more than one way to make 4 terms. I can split 5 up in a billion different ways. That's the only way that's going to make it work. So now I group. So what comes out of here? 2x.
X plus 2y.
And what comes out of these two? This poor little dude. A y. X plus 2y, thank God. Why is that a good thing? These are the same. If they were not the same, don't go forward, because then you're doing magic, right? This is, they have to be the same to even be able to do the next step. The next step is 2x plus
I
y.
have a question.
Yes?
So how can you pull the 2x out of just the x and y? You know?
Where am I at? Sorry? So right here, these two, I sure did, out of these two.
Oh, okay. I thought it
So
was the
group
whole
these
thing.
2 and these 2. So out of these 2, what did I pull out? A y.
Oh, okay.
Yeah. So there's 1, 2, 3, 4 terms. I took something out of the first two and something out of the second two. Good. So that's grouping is kind of a way around. GCF normally you have to take something out of everybody. Grouping says, no. If you got at least 4 terms, just look at bam, 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 right? So then you can take different stuff out of each.
But is that in the correct order? Like, would it be 2x squared plus 2y squared plus 5xy?
Oh, no. The middle term will almost always be the mixture term. When I say that, do you see what I mean? You got x's, you got y's. The middle term should be the one that has both of them.
So you don't.
Because he's the one that multiplies across. He's going to have x's and y's. In it.
So if you, because I would have put it in order.
This is in
That
order.
is in
Oh.
order.
Yeah.
I don't-
Watch. It's in descending order of x. Where's the most x's?
On the left.
Here. Where's the least x's?
In the middle.
There. So it's descending order of x. If you turn these around, it would still work. Just my y stuff would be out front then, right? So then it would be descending order in y, but it's still the same idea. Okay, good. What about this guy? Yeah, good. I can see x's in all of them, so take an x out.
X squared. Negative 2xy. Plus 4y squared.
4y squared, yeah. And why do you not spend any time on that? Because you see it over there, right? Whenever you have a cube, be careful about trinomials. Don't tear your hair out trying to go further because that will never work. It doesn't need to. It's going to cancel with this guy. What about the last piece, number 4?
Take out a
Take out a 2.
4x squared.
Minus y squared.
And now you can back them out.
Good.
2x minus y, 2x plus y.
Cool. I like it. All right, cool. How we doing so far? All right. Now, a problem like this is exactly the kind of problem students get to a certain point. They're like, I did enough work on this. Go to the next one. Each step should not be difficult. If you still are not able to factor cubes, you must come see me or see somebody or get that down. Each of these should not be like horribly bad. It's just the fact that they all are the same damn problem that our brain goes, oh shit. But you treat this as one problem, you treat this as another problem, and then you bring them all back together. Now we're going to be able to kill a lot of stuff, right? So now I just put it back together. So let's see. See if we can handle also at the same time. What do I have to do with that division?
Flip it.
So that first spot, I'm going to put this dude. Down below, I'm going to put the second dude. Let's see what we can do this. Times. Now I'm going to put the fourth dude on top, right? I'm going to flip that guy. And then the third dude's going to go on the bottom. Next time, the big dude. Coolness. Right? And now I just go to town. All right. Big dude dies. Bye, big dude. What else dies? Yeah, 2x plus y. Dead. X plus 2y. Dead. So then I end up with on the top.
Over x.
What? Most people normally are okay with the fact that we condensed all that. But some people are like, oh, it's all that crap and it's just this? What? No, I'm like, no, come on, it's awesome. We took all that crap and we made it just that. It's awesome. Let it be awesome. All right.
All right, quick question.
Yeah.
So last one, number 4, could you just go through that real quick on how you factored that?
Yeah, let me pull it over here. If you try to do anything other than GCF first, you will fail. Is it a squares the way it is now? Is 2 something squared that's nice? No. It's a square of 1.414 blah 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 blah. That's not a nice number. So that's not a perfect square. That's not a perfect square. So the right answer still is in prime, you always try GCF first. So we took a 2 out first. And now is this a squares?
Yes.
Yeah, everything is, I can cut everything in there in half, right? So then it'll be half, 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 plus minus. Or minus plus, who cares? Sweet. That's your thank God problem, or thank whatever deity you want. Right? If you pray to coffee, thank you, coffee.
How did you know?
Praise be to coffee. Okay. Yummy. Look at that problem. I like that problem. It took up the whole board. That's awesome. All right. I remember being in a classroom where the teacher just kind of started there and went around the room.
Oh, good.
Oh, yeah. We just kind of turned our chairs. Okay. Anything else from homework before we get into...
7.4.
Go ahead.
7.4, number 40.
Oh, yeah. Okay. Let's see. I need some room here. Everybody sat this year? Let's see. The one with 1 minus 6m, right?
Yeah.
Now this one, I mean, that is a what? Well, can you? Hey, guys. Carl.
Help factor anything?
No, I'm all right, Carl. You gonna be around?
Yeah.
Good. All right. Escape. So this is a cubes, but why do I not even care about that? Yeah, because this is almost the same as that. They almost already have LCD. I don't have to factor it if it's already an LCD. So all I have to do here is,
Pull out a -1.
yeah, even better, I multiply top and bottom by -1. I can multiply top and bottom of a fraction by anything except 0. So the top's going to become what?
6 and minus 1. And
And written like that, even better, right? Cool. So then when you apply a negative to it, it just kind of flips the order there, right? And the bottom, of course, is going to become, which kicks ass. You don't even have to factor this. Now, if you did, it's not wrong, but you don't have to. Because they're already like terms. Nobody's going to be missing anything. They have each other. So then the top becomes, yeah, 6n minus 1 minus 5. I like it. So 6n minus 6.
m cubed minus 1.
Now you might want to do what? Yeah, at least that. Now you got to see if anything cancels. So now you do have to factor the top and the bottom. How are we doing so far? Is that cool?
Yeah.
So always look out for when they're just off by a negative. If they're just off by a negative, then give one of them a negative on the top and bottom. Now they're the same. So the 6 comes out of the top. And what can I do with the bottom? Yeah, it's m. So it's m minus, and of course 1 is however many 1s you want. So then the other two m's
Squared.
plus
Like,
m, and then the other two 1s. So of course what cancels?
And minus 1.
M minus 1. So then you just get 6 over that.
How do you know that's an n squared plus?
Well, if that's a minus, that's a plus. Because what's his job? What is this guy's job? Cleanup dude, the cancellation guy. He's got to be the opposite sign so he can kill the stuff I don't want. So soap is an awesome little thing. It's fine, but make sure you can also back it up with why it makes sense. Why is it the opposite? Because that's the cancellation guy. He's got to be the opposite sign so he can kill all the stuff you don't want. Clean up the mess in the back of the car. Right? Okay. All right. Anything else? Well, you had...
9.6 over 25.
It's going to be a little harder to keep track. where I am. If I'm in the shot, I make it all blurry. All right. Number 25?
Yeah.
Oh, yeah, good. All right. Bye-bye. So real quick, a little side note. If I had x squared plus 4x plus 4, and that's easy enough to factor, right? How do you factor that? Careful. Yeah. The middle term's there, so they can't be opposite sides, right? Now, if I wrote this instead, have I written a different problem? Is that a different problem? No, it's the same problem, just out of order. Right? So it doesn't change things at all. You would just put it back in order and do it like we just did. So this one's got that kind of thing going on. Number 25 and 9.6. I almost can remember it. I've looked at it enough. Yeah. 5mn. So this goes back to what I was saying earlier. What should be in the middle? Yeah, the mixture term should be in the middle. Squared stuff should be on the outsides. Right? So if I just put the m squared first, it's a little bit better to look at. Now, what's the first number? 1. So now that should be a relatively easy problem, right? The only other thing that could throw us off is these n's. But what numbers work?
15.
Yeah, which one's negative or which one's positive? 15's positive to make the middle term positive, right? So I know it's going to be m squared. It's going to make it
M plus 15.
so m squared to make it m and m, right? Please stand up. And then n squared.
15.
What does it do at the end? The same way that the m's at the beginning make the m squared at the beginning, the n squared needs n and n. So don't let that throw you off. And now you just put the numbers in. We figured out plus 15 minus 10. So you guys are catching up with that. So don't freak out. Now, why does the middle term totally make sense? What I was saying earlier about mixture. 15 mn minus 10 mn. Right? So the middle term is going to be mixture because it's the one that goes across and mixes the variables if there happens to be variables in both places. All right, maybe. You good? All right. Cool.
So why is the M and N like? Why isn't it 15 MN and 10 MN?
Because then the last term would have to be m squared n squared, right?
Okay.
It's supposed to be n times n squared. Do you see that?
Yeah.
So the only reason these are together here is because it goes across like that. So m squared, m, n squared, and n. Then you just figure out your numbers like you normally would. All right, hopeful. Always hopeful. Okay. So maybe one more. Any other questions? Yeah.
42.
All right. Let me see if I can not do this whole problem. Let's see. So the main problem with number 42, when you first come to it, is again, I can't just say d equals 40, d minus 3 equals 40. Right? You can't do that. If they were both 40, then it wouldn't multiply by 40. That doesn't make sense in the first place. Yeah.
Don't you equal it to 0?
You have to.
Yeah.
But how do you get there legally? You can't, I'm not picking on anybody, because I've seen this a few times, but you can't suddenly just put that in there somewhere. I understand why your brain might go, I don't want to factor stuff, let me just throw it in there, it's already factored. But you're not allowed to break into this multiplication with a subtraction, right? So what do you have to do with this?
Distribute.
And then you can subtract 40. Now this you just factor, set each factor equal to 0.
Okay.
Yep. Cool. Yep.
Which rest of the homework did it go on my math line?
So I got up to chapter 10. I haven't put 11 yet because I wasn't sure how far I'd get through 11 today. And what I'm going to do with, I'm still thinking actually in the back of my brain.
And when's the 7.2 start due?
Oh, well, today, everything is due Monday. So basically, anything you haven't turned in today, you have to have it done by Monday. or else it'll be late. You can still turn it in after Monday, and the sooner you turn it in after Monday, the better everything is. Right?
Up to what chapters am I trying to figure out?
Up through at least 10:3, and then however far we make it in chapter 11. Oh yeah. 3-week course. Yes.
If you were to turn in your homework by Monday without getting it corrected and you still needed to do corrections, would it be inputted as like half credit, or like if you were to turn in your corrections after Monday?
Homework corrections aren't due until the day of the final.
Oh, they're okay.
So
That's
when I give it back to you and I say correct, you have half credit on that at the moment.
oh,
You do corrections by the day of the final, get enough right, you back up to 100%. So real quick on the My Math Lab, I don't take, like if you get, at the end, you get like an 86.3%. I'm going to treat that as 100. Because I let the people in textbook make mistakes. You with me? I let the people in textbook, I'm going to put okay, even though you got a couple wrong. All right? So I do the same thing on My Math Lab. If you hit a certain level, normally I kind of look at the problems that you missed to make sure there's not huge conceptual mistakes. So if you got a certain level, it's going to be a full homework grade. Right? Does that make just like in the textbook? Good. All right. Good. All right. So let's get back into, let's do a problem from section 10.3 before we get into chapter 11. And we're going to declare bankruptcy. Let's remember how to do this. We'll do 2 problems from 10.3. We'll do a problem with 1 part and a problem with 2 parts. Let's see. You can do it, Jeff. Yeah. So the fact that the problem has an x and a y in it is a clue that you have to do it like this. And on the test it'll be a big clue because I'll probably give you this so you can put it in there. You with me? It's going to be a huge clue. What do I have to do first? Yeah, get y by itself. So subtract x. For some reason when people do this, they get this. What have I done wrong?
The negative.
Yeah, I left the negative out. That negative is still there. It's minus, but it's also negative. It's both at the same time.
And then doesn't sign flip because you have to divide by negative.
I didn't divide by a negative or multiply by negative, right? Just subtract it. So again, if 7's bigger than 6, is that true?
Yes.
Yes. If I subtract 1 from both sides, do I have to flip the sign? No, it's still true. It's only if I divide or multiply by negative that I got to switch the sign. Now, on the next step, now what am I going to do now?
Divide by negative
Now I'm
3.
going to divide by negative 3. You were just ahead of me. So then this cancels. So this becomes greater. 1/3 x plus, or is it plus still? Minus 4. I like it. Cool. Notice how everybody's got to be divided by negative 3. Nobody can escape. You can't pick and choose which one to divide by negative 3. So what's my slope?
1 over
1/3. So I'll go up 1 over 3. All right, you drive me crazy.
Yes, sweet.
So y-intercept 0.
-4.
Negative 4, cool. All right, so go ahead and try to graph that. The key thing with inequality graphing in 2 dimensions, you better shade. If you don't shade, that's the whole point of this. You're going to lose the bulk of the points. The shading is the answer.
It has to be a dotted line, right?
Good. Cool.
were to plug it, oh, just kidding, never mind. I answered.
Or you're just telling it's dotted instead of solid.
Yeah.
Take a point normally 0, 0. If it works, you shade in that direction. 0 for example. So if you end up with a true statement, that side works. If you have a false statement, the other side works. Yeah.
That's right.
So I got my y-intercept 0, -4. Then from there I go
Up
up 1
over 3.
over 3. And
Down
like
one.
you said, it's got to be dotted line. Now if you plug a 0, 0 in, and again, I always just go to the beginning. It makes it a little easier. Plus, if you made a mistake on the way here, it's a little better to go up here. So if you plug a 0 in, is 0 minus 3 times 0 less than 12? Is that true?
Yes.
0 is less than 12. True. Which means
Shade.
this side works. If that was false, then the other side would work. Right? So now I just shade. Whee! How we doing? All right.
Where do you plug in the 0? The first?
Yeah, so the point, I'm going to use this this test point here of 0, 0, and of course, the general point is
No,
x,
just the
y.
X.
So I just
Wait,
plug a
no,
0
it is
in
the
for
Y.
x and a 0 in for y.
That's
You,
right. Yes,
you
it
can't
is.
plug it in the.
You totally could.
I wasn't sure
Yeah,
about
sure.
that.
You can say 0 greater than 0 minus 4. 0 is bigger than -4. So that still means it's true. But again, if you made a mistake going down here, I always like to go to the original just to make sure I don't have like compound mistakes in my problem. All right, so, yes, sir.
That's when it says obviously, do you want us to always use the 0, 0, 1 to check it? So
I don't care. You could use 1.8 comma negative 14.7. You can use any point you want to.
Well, I was just talking about the way that you did it. You want us to use
Gotcha. The way I would do it is where are all the outputs bigger than that line?
Yeah, that's the way that I do it.
I love it. Right, so here's the y on the line. Where are the y's bigger than that? Up. Yeah. And this one's a really small slope, so up and down makes sense, but when it gets to be like this, up and down is a little weird. So that's why I understand test point makes it a little more
The
clear.
12 represents the line.
The 12?
Yeah.
The 12 represents what these, so all the values that make this 12 are what are on this line. And that's why it's dotted, because it's not allowed to equal 12. So so you can't say the line is represented by 12, but 12 is what the points on that line, when I plug them in here, they make something less than, they make something equal to 12. You with me? So if I plug any point on this line in here, it'll be 12. You guys believe me? That's the main idea of a line, right? That's how I graph that point, is I get points that work in this equation. So why is it dotted? Because I can't equal 12. If it was less than or equal to 12, then I would have shaded the line in, made it solid. Because then I would include those points, because all those points make it equal 12. But it wasn't. Now the shading is, all these points actually make it less than 12 when I do this. So let's try this out. What point is this? 2, 1. So if I plug 2, 1 in, what should happen?
Should be less than 12.
Should be less than 12. So sure enough, I plug in 2, 1, I get 2. No, Jeff. 2 minus 3 times 1, is that less than 12? Check. So any point you pick up here. So that's why it doesn't matter. If I would have used this as a test point, it would have still shown me to shade up. Just pick a point that is on one side of the line. Cool. I like it. And again, if this would have been false, I just would have shaded the other. He doesn't work if that's false, so it must be everybody on this side. So it's got to be one side or the other. All right, bride or groom side. I want to sit in the aisle. No, dude, you're weird. Bride or groom, right? I don't know. Whatever's going to make it make sense.
I like both of them. I'm going to lay across the aisle.
No. They can hurdle. No, stop. All right. So, without making an entirely new problem, because we've got all this beautiful work up here, the other kind of problem you're going to see here is not just going to have one equation, it's going to be a system of inequalities. And the reason it's not a big deal is you just do one all the way out like we did. So let's say that this problem, you guys have all this work here, right?
Yes.
Say this problem was graph the solution for this and this. And what, I don't know, man. I can't come up with all this stuff. You could do it. Sure. So if you were given a problem that had two of these, you take one, do it all the way. Take the other one, on top of that, you do that one all the way. And then let's see what we think the answer is going to be. Oh yeah, I keep going back. So you should be getting this when you solve for y. So what's the y-intercept?
0, 3.
I like 0, 3. And then I go
Down to
Over 5.
over 5. Down to over 5. You can do it, Jeff. There it is. And what kind of line is this going to be?
dotted.
Dotted. It's going to work big. All right. Let's make this a little clearer. And then, if you plug in 0, 0, is 0 plus 0 less than 15?
Yes.
Yes. Cool. So then I'm going to shade down. Or less than, I'm going to shade down. Right? So then you shade down. So the answer, so when you do this on the work, you don't have to do all these lines. You might just want to put one little arrow so it's not like a bunch of crap on there. But you want to shade in darker. The answer is going to be everything in the middle there, right? So, what would happen with that 0.21 now, since it's in this area? So the purple shaded area works in the first one. The blue shaded area works in the second one. So of course this black shaded area works in both. So this point works in one, that point works in none, but this point works in both. So that's why that's the answer. That's the area that works in this system, in both things at once. So it's where the shading overlaps, right? So this kind of problem in real life would be something like, I'm talking about power. I don't want the power to be more than this, and I don't want it to be less than this, so then I'm in here. So if it's more than this, it blows up. If it's less than this, people don't have enough power to turn on their heaters, right? So this is the safe area to be in. So it's called not just wrong on my head. It's constraints on a system, right? So engineers get this all the time. You're trying to engineer something that can withstand earthquake forces and winds and stuff. And You want to get your safe area to work in. If you build out in this area, the damn thing's going to fall over. Probably a bad thing for your company, right? So it's the idea of finding safe areas. Where do you want to be? Where's the sweet spot? So nobody dies, right? It's a good thing. So that's the kind of thing that this exact mathematical work could be used for in the real world. Okay, so how do you feel about that? Is that decent? All right, so if you can graph lines, that's almost easy as hell. Right? As long as you can graph the line, it's pretty easy. So I think what I want to do, I think I've made a decision, is I want to do section 11.1, and I'm going to make, what the hell? I'm going to make section 11.2 extra credit. You guys hear me?
11.2.
Yeah, normally those two words perk people up. So section 11.2, extra credit. So online, I'll put it up online. It'll be worth 0 points. And at the end of the semester, I'll just see if you did it, and I'll boost your grade up. You with me? Textbook, you do it if you want to. You don't do it if you don't want to. And to be honest, they're word problems, but they're actually much easier than the other word problems. We just need more time. I just want to have more time to review today. But we're going to do section 11.1 still. That's homework is definitely still due Monday. Okay. So, you guys, let's do one example of a problem. So, section, what did I just say? 11.1. Section 11.1 deals with what if I have 3 variables instead of 2? So, hopefully I've said this enough. If I have 2 things I don't know, I must give you how much information? 2 pieces of information. So, if I have 3 things I don't know, incredibly enough, I have to give you 3 pieces of information. So now if I have X, Y, and Z, they have to give me 3 equations. Cool. So now we're actually getting closer to real life. Why is it so difficult to predict the weather?
Because of a lot of variables.
Kick ass. That's exactly what there's a lot of variables. Too many freaking variables to really, and they all interact with each other. Holy crap, I would never want to be a weatherman. Maybe here. It's going to be around 70. See you later. All right. It might rain. It might not. So I actually have a handout where I try to spell out the steps, but I want to try to do it first up here, and then you have this to reference. Maybe I should do the exact same problem. Maybe that would be good. I'll tell you what. No. I'm changing my mind midstream. Let's. I'm going to show you how I create a problem. So, what does the answer look like to a problem like this here? What would the answer look like? Let's go ahead and get the answer. How do I get the answer real quick? What can I do?
Elimination method?
Yeah, good. Elimination method. I can kill the y's. So I'll get
2x.
X is 3. And then I can plug that back into like 1, for example. Either 1, really. But I get 3 plus y equals 4. So y is minus 3, right? So y is 1. So this is okay, but what really does the answer look like?
An ordered pair.
Good. A point. An ordered pair, even better. Because that point would be where what happens?
Where they intersect.
Where these 2 lines would visually intersect, right? So this is the algebraic method, but the answer should still be agreeing with what do I get visually. And there it is, the 0.31. So if I have 3 variables, somebody give me a number.
2.
2. Somebody else give me a negative number.
-3.
Negative 3. Somebody else give me a third number.
7.
7. I think I heard. Freaked me out because that's what I was. So he was like 5. I want 5. Screw guys. I'm out of here. Didn't get my 5. So here's now. Obviously, this is not what happens in the real world. In the real world, we make an observation and we write down an equation that matches our observations, and then we make another observation, because I need 3 things. If there are 3 things I don't know, I need 3 observations, right? Here, I'm kind of starting with the answer to construct a problem, so I know the problem's going to work well. Are you with me? If I just start writing x plus y plus 14z equals 7, it's probably going to have a really heinous answer, right? It might not even have an answer, and I want it to have an answer. You guys got it with me a little bit? So let me do the first one just to get us rolling. So let's do one that's kind of nice. X plus y plus z. What do I have to put here if I want that to be my answer? Why do I have to put 6 there? Because that's what 2 minus 3 plus 7 is. Do you guys see that?
Yeah.
So I like this. I like that. I want to show you kind of how I can construct a problem and know what the answer is going to be. I just can't make a problem out of nowhere because, my God, the answer could be 110 over 1437, and I really don't want to do that to you too often, right? So here, this got to be 6 because 2 minus 3 plus 7 is 6. So let's make a more interesting combination here. Maybe negative 2x minus 5y plus 3z. All right, you guys are starting to understand now. I like it. And now what's that got to equal? Oh shit, let's figure this out. I don't know if you guys are with me. So it'd be negative 2 times 2, right? X is 2, y is negative 3, z is 7. It's always alphabetical order unless they tell me otherwise, right? There's that one CD problem, the homework you have to be careful of.
Is it 2? I mean, final?
Say again, sorry?
Should be 2 at the very end. But
oh, I don't know. Let's find out. So negative 2 times 2 minus 5 times negative 3 plus 3 times 7. So what's this? It's be negative 4
15
plus 15
21 plus 21
plus 21.
oh, yes.
You guys see that?
Yeah.
So it'll be 36 minus 4, 32.
What?
So we're just plugging things in?
Yeah, and I really want you to understand, this is nothing to do with your homework. You never have to do this yourself. This is how you create a problem and know what the answer is from the beginning. I know if I want the answer to be this, then I can start just putting some